How are you, my friends? This is another video on basic math terms. Just to remind you that part 30 was the start of Calculus 1 terms. Also, the algebra terms, you can find them in parts 1 to 18. Pre-calculus terms, you can find them in parts 19 to 27. And statistics terms, you can find them in parts 28 and 29. So this is part 32 from Calculus 1. Derivative, so the verb is differentiate. Differential notation for the derivatives, rate of change, average velocity, instantaneous velocity, speed, the power rule, the product rule, the quotient rule, the reciprocal rule, chain rule. There are 3 forms, and generalized power rule. So let's look at these 12 terms. So the derivative of a function, we can find it by this formula: f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. Now, to find the derivative, you can follow these 4 steps until you find the limit of this difference quotient. So this is the derivative. The derivative can be as slope predictor for the tangent line. So if we find the slope, m equals f prime at a, see this is number a, value in the domain, find the derivative f prime, replace x by a, that will be the slope of this tangent line. So to find the equation of a tangent line, we need that a lot in Calculus 1. You can use the formula from the Algebra Course: y minus y1 is equal to m times x minus x1. y1 will be the image of the a, f of a. x1 is the a, and we can leave x here to get, and this m will be f prime at a. So this is the equation of the tangent line. Now, differential notation for the derivative, we can say f prime of x. So the first one, we can read it as f prime of x, which should be the derivative of f with respect to x. So in this slide, you can see the notations. Y prime, just treat it like that, y prime. So this is the derivative of y. dy over dx, dy over dx. This is the derivative of y with respect to x. All of these 5 notations, the same meaning. df over dx, so we say df over dx, the derivative of the function f with respect to x, or d over dx of f of x, the derivative of f of x. The rate of change is a nice application for the derivative, the rate of change of a given function with respect to an independent variable. Suppose we have q of t is a quantity that varies with time. Then the instantaneous rate of change will be dq over dt, which is f prime at t. Now, for example, this q is a quantity. It can be size of a population, number of dollars in a bank, it can be volume of a balloon, it can be distance traveled in t hours. So it can be anything. To find the instantaneous rate of change, just take the derivative f prime of t. Now here I will show you what is the difference between average speed and instantaneous velocity. Average speed is average velocity. So it will be the distance divided by elapsed time. It takes you, let's say, 4 hours to drive 200 miles. So we just say the average speed. Take the distance and divide by the time. It will be 50 miles per hour. That is the average speed or the average velocity. Now, the instantaneous If you need the velocity at a certain instant, so it will be v, the limit as delta t goes to 0 of delta x over delta t, which is simply f prime of t, the derivative of the function, and f of t is the position function. So the velocity is instantaneous rate of change of the position. Velocity can be positive, can be negative. If we say find the speed, it will be the absolute value of the velocity, which is positive number. Now, these are rules for finding the derivatives. They are very helpful. The power rule, we have f of x is equal x to the power n. F prime of x will be n, bring the power down, times x to the power n minus 1. And there are many examples here. You can see that also in the lectures. You can read all these examples. Look at this nice one here. If we need the derivative of square root of x, so we can write x to the power half, bring the half down, subtract 1, it will be minus half, then the final answer will be 1 over 2 square root of x. So you can practice on these examples and also in the lecture. The product rule. If we have the derivative of a product, f of x times g of x, you can write it as f prime of x times g plus f of x times g prime. Or we can say the derivative of the first times the second plus the first times the derivative of the second. Or the formula I normally use here, uv prime, that's the same as the product rule, u prime v plus v prime u. This is easy to remember if you like that. The quotient rule. Quotient means f of x divided by g of x, and we need the derivative of this quotient. It will be the derivative of the numerator here, f prime, times the denominator, g, minus, there is a minus, g prime of x times f of x, divided by the denominator all squared. This is the formula I use, u over v all prime. U prime v minus v prime u all divided by v squared. If you like this formula, you can use it as a quotient rule. Now, the reciprocal rule, if we have 1 over a function, any function can be there, 1 over that function, we need the derivative. So it will be minus f prime, the derivative of the denominator, divided by the function squared. Or you can use my rule here that I use, 1 over u prime minus u prime divided by u squared. It's up to you. Now, the chain rule, we have the derivative of a composition, f circle g all prime. So it will be f prime of g of x times g prime. This is the chain rule. So this is one form. Another form, if we have u equals g of x and y equals f of u, and y will be f of g of x, which is the composition f circle g. So dy over dx is equal dy over du, because y is a function of u, times du over dx. You can use this for chain rule, or you can say directly the derivative of f of u will be f prime of u times the derivative of the inside function du over dx. Now, the generalized power rule, we have a function here to the power n. You can see many examples in the lecture of the derivative. So we need the derivative of a function g of x all to the power n. Bring the n down, see the power rule. G of x is a function to the power n minus 1 times the derivative of the inside. So that's why we call it generalized power rule. I will show you now quickly. Look at the power rule. We have only x to the power n. And now if you multiply by the derivative of the x, which is 1. So the power rule, x to the power n. The generalized power rule, we have a function, not only x, to the power n. So it will be n times g of x to the power n minus 1 times g prime of x. Or you can use that one also, the same as generalized power rule. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.